In this video, I'd like to talk about how to factor the difference of two squares. So you're going to be given this expression and we need to factor it into two binomials multiplied together. Now the first four problems that I'll focus on will be simpler ones from the intro exercise, and the last four problems will be from the more advanced just difference of squares exercise, so not the non-intro exercise. So before we jump into the problem, let's just think about what a difference of two squares is as a refresher, or maybe it's your first time learning it. And basically, a difference of two squares is when you have two numbers that are squared and you're finding their difference. And a difference, remember, is subtraction. So something like 4 squared minus 3 squared. This is technically a difference of squares, since you have something squared and something else squared, and you're finding their difference. You're subtracting here. So you can see that for this first problem, you have x squared, this one squared, minus 2 squared. So you do have a difference of squares here, and these all factor pretty much the same way. Notice numerically, I'll do it numerically first, and then we'll do a more variable type problem. And this is 16, and this is 9, so you do get 7. But I want to show you that you can factor this as the first one, disregarding the square, minus the second one, so 4 minus 3, and then it'll be the first one plus the second one. And notice that this does equal 7, since this is 1 and this is 7, and those multiplied together do give you 7. So this is how it's always going to factor. Like, let's say you have a squared minus b squared. So this is the very general form. When you factor this, it's going to be the first one minus the second one, ignoring the squares, so a minus b, and then the first one plus the second one, so a plus b. So in both cases, if you can figure out what is squared, then you can just plug it into this formula, essentially. And make sure you understand how to re-multiply out the formula, since that's how we're going to check our work. So a is going to multiply to both of those terms. So you get a squared plus ab. And then b is going to multiply to both of these terms, actually negative b. So you'd have minus ab and then minus b squared. And notice this plus ab minus ab, those cancel, and you do get back a squared minus b squared. So essentially this kind of proves to you that this formula is valid. If you just re-multiply it out, you get back what you started with. And this always happens where these middle terms cancel out. That's a common theme with these difference of two squares. So this is the formula that we're going to use. Let me just back up so that's a little bit nicer looking. But we'll use this formula in yellow to solve all of our problem types. So let me just box this in here. And like I said, you just need to figure out what is squared in each of these. So this was x squared minus 4. I figured out that 4 was really just 2 squared. So it's like this is our a and this is our b. And now we just plug them into our formula. So a, that's the x, but without the square. So you have x minus b. And again, it's the number without the square. So x minus 2. And then it's the first one plus the second one. And this is how it will always be. First one minus second one, first one plus second one, and you multiply those together. But let's check it before we assume this is the final answer. We think this is the answer. We think this is a fully factored version of x squared minus 4, but the only way to know for sure is if you re-multiply it out. So the x distributes to both, or you can use the FOIL method, but this effectively is the FOIL method. So x times x is x squared, x times 2 would be plus 2x, and then the minus 2 distributes. So we are checking our work here. You want to do this with every problem. You have minus 2 times x, which is minus 2x, minus 2 times positive 2, which would be minus 4, and notice the middle terms go away, and you just get back x squared minus 4. So we checked it, it did work, which means we can feel confident that this is the right answer. That you get x minus 2 times x plus 2. So let's use this pattern, this formula, to solve all of these problems. So moving to the next one, we just need to figure out what is squared in each of these. So I'll rewrite the formula, a squared minus b squared. It's the first one minus the second one times the first one plus the second one. Now we have 1 minus x squared. So 1 is really just 1 squared. And we have this x squared as our second one. So essentially a in this case is 1 and b is x. So when we factor this, we get a minus b, so 1 minus x. The first one minus the second one, ignoring the squares. And then it's the first one plus the second one, so 1 plus x. And when we remultiply this out, so now we're going to check. So let me just write it down. Remultiply the factored form. And once you do that, if you get back what you start with, then you know you did it correctly. So remultiplying it, 1 and 1 make 1. 1 times positive x would be plus x. Minus x times 1 would be minus x. And minus x times x would be minus x squared. The middle terms go away, and you do get 1 minus x squared, which means that this worked. So you can feel confident that this is indeed the factored form for this expression here. And let's keep going. So this one you will sometimes see where you have a picture. And we know the rectangle has an area of x squared minus 144 square meters and a length of x plus 12. So that's our length here. And we need an expression that represents the width. So we have this x squared minus 144, and this is equal to x plus 12 times by the width. But we're doing a difference of squares problem, so we can factor this as a difference of two squares, since we really have x squared minus 12 squared. And so it's going to be the first one minus the second one when we factor it, so x minus 12. And remember, when you put it in parentheses, you ignore the squares. And this is the first one plus the second one, x plus 12. And notice we have x plus 12, but we don't have the x minus 12 for our width. So that's what it would have to be. So our width here would just be x minus 12. Since if you multiply x minus 12 times x plus 12, if you multiply these out, you do get back x squared minus 144. I encourage you to pause the video and try and check this yourself. But in the box, once you do check it, you'll see that x minus 12 would have to be our width here. Now let's keep going. We've got one more from the intro exercise. And so let's finish that, and then we'll start looking at the more advanced exercise. So in all of these, you really just need to figure out which numbers are squared. So 36, that's just 6 squared minus x squared. And so when we factor this into its difference of two squares, we put our two binomials. And it's the first one minus the second one, so 6 minus x. And then it's the first one plus the second one, so 6 plus x. We can multiply this out to check. 6 and 6 make 36. And then 6 and x would make 6x. Minus x and 6 would be minus 6x. And minus x and x would be minus x squared. And notice the middle terms go away and you get 36 minus x squared. So when we checked it, we knew for sure that this was the right answer. So checking it allows us to feel very confident that we actually did it correctly.